All right, happy Saturday morning. I'm back in the garage. I just finished my mock-up battery tray. It's basically just foam board with my CAD drawings printed out and spray mounted to it. What I'm trying to do here is get a fit that is going to work not only for this juncture here where the tray is going to be welded to my seat rack, my seat bracket, but I also want to make sure that it's narrow enough that this edge, get out of here mosquito, this edge of the tray isn't sitting on the radius of my transmission tunnel, because that could be a problem. Over time, I could see the edge digging through my bed liner and inviting rust into the body, and that's a bad situation. Also, I need to make sure that I have enough lip on the front edge of the tray that, God forbid, if I'm ever in an accident or I ever have to stop really quick, not like this Jeep is going to stop really that quick, but regardless, I need enough of a lip on here that it's going to stop the batteries tumbling forward into the passenger seat. So I need to keep those batteries nice and snug underneath the bench seat here. Okay, I got some good progress from the first study model. Getting more detailed now. What I find from this study model is that the base of the tray wants to be a little bit deeper. I'm going to add probably 2 mil to make it deeper, because when the batteries are in here, they're actually up against these walls and pushing the walls out. So they need a little bit more space. And on the topic of space, I decided to ditch the terminals that came with the batteries originally, and in favor of a lower profile cap screw. It's kind of funny. These have these nice big bolts on here that go into the terminals. But if you look at the bolt that attaches the terminal to the actual battery, it's the same size as that one there. So what's the point of having a big bolt into a smaller bolt? Doesn't really make sense to me. And so by switching to a smaller bolt, a smaller screw, I'm actually lowering the profile of the battery so I can get it close. I can tuck the batteries closer to each other when they're on the tray. I'll show you here. Once the batteries are on the tray, I can get them a good bit closer, enabling me to skim about 4 or 5 mil off of this end of the tray. I want to raise the front lip of the tray up a little bit. My concern with my earlier model was I don't want to cover the battery call out number. So I made these really low and they ended up a little bit too low. So I want to add another centimeter to the height here, and same as on the back. I'm going to add a centimeter in height to those. And something else that I want to do is move my pole designations to where I can see them when the batteries are installed. So do you see this negative? That's the negative for this battery. So whenever I pull the batteries out, I know exactly where to put them back in. I don't even have to think about it. So I want to move. And also when the batteries are in, if I ever need to change a wire or do something in here, I can see exactly which side the negative is, which side the positive. So I'm going to move these terminal designations to the center. This one here to the center. So when I'm looking down at the batteries in the tray, I can see, oh, okay, that side is negative. Oh, this side is positive. And so I'm not crossing wires or blowing fuses and all that. Another thing I need to do is cut a mouse hole here. So these two wires have a place to come through. This wire is the negative going to the shunt, and this wire will be the hot from the isolator, which eventually makes it to the starter battery and the alternator. So those two wires need a way to get in to the wire network that's going on in between these two batteries. So they'll come through that wall there. Yeah, so that's pretty much it as it stands. Once I got to get some more of these screws from the hardware store. I'm going to get some fresh ones. These are actually cut down, and I only had two. So I'm going to get those screws. I'm going to redo my edit my drawing and redo one final study model, and hopefully by Monday morning I'm ready to send my drawings to the machine shop. All right, my battery is dying, so I got to make this quick, but this is the third and final study model. I think I got it. I got everything straightened out. Like I said, I raised the lip up another centimeter, so I'm grabbing more of the battery, but I'm not blocking the part number on the battery. I shortened it in this dimension, I believe 4 millimeters, and I deepened it 2 millimeters. So I'm not pressing the walls out anymore. I mounted the shunt on this one just to make sure that my wires are going to go where I want them to go. Obviously the steel version of it won't have these webs. This is just to support it. But so this will be the wire that goes out to the isolator in the engine compartment. That'll come in through this hole right here that I made, and into the wire, that'll go into this battery. And then I have the negative line for the shunt comes out of this battery and into the shunt right here. As I was saying, I was able to squeeze the batteries closer together by getting rid of the old terminals. You can see the height difference in the terminals. This is what came on the batteries, and this is what I came up with. I got these Allen head cap screws from the hardware store, and I made these spacers out of steel plate with a hole saw. Yeah, so everything works out. Everything fits up. This side isn't going to rest on the radius of the transmission tunnel, and this side fits flush against the bench seat bracket, which it's going to get welded to. This is it. All right, so I'm on to charging. This was one of the more difficult parts of this project, due to the fact that my battery bank is really small. Most of the battery banks that people are doing for overlanding and for RVs and stuff, they run anywhere from 100 to 200 and up amp hours. And my battery bank is only 56 amp hours. So almost all of your DC-DC chargers that you would use to charge a battery bank, they are made for banks that are anywhere from 100 and up. So that kind of ruled out DC-DC chargers for me. There's a lot of back and forth about DC-DC versus smart isolator. But what I've learned from tons of research is that DC-DCs they're best. Especially they're necessary they're absolutely necessary if you have a newer vehicle that has a smart alternator. But for a Jeep, the age of mine, I can get away with a isolator, but I'm gonna have much better results and more safety features with a DC-DC charger. So I was under the impression that there wasn't a DC-DC charger made for a battery bank my size. So I ordered this one. Unfortunately, a couple days after this arrived, I actually found one, a DC-DC charger. It's made by Red Arc. It's called the BCDC 1212T. And that's made for, basically made for trailers, like winches on trailers and stuff like that. So that's the perfect spec for what I'm doing. Unfortunately, I have this one here now, and also that DC-DC is coming from Australia. Red Arc is based in Australia, and I wasn't able to find that model on Amazon where I bought this one. This one was like $85 shipped. So I'm gonna run this for the time being. I just need to watch that I don't run my batteries too low. That's one of the perks of a DC-DC is that it keeps an eye on that, and it won't let you overcharge your batteries. The problem is if you run your battery too low and you have an isolator hooked up to it, when you kick your engine on and your alternator starts charging, it's going to send a flood of current to your battery bank to get those batteries back up to to where they should be, and that's not good for the batteries. So I need to watch how low I'm draining my bank. But I don't think it's really going to be that big a deal for me, because really I have very modest needs for my bank. I'm running a fridge and maybe an LED light or two, maybe a fan. So I'm probably never going to go below 80-85% of my batteries, my bank's capacity. So this should do for now. I will go to the DC-DC in the future, but not at $80 shipping charge from Australia. All right, so I'm pretty comfortable with the diagram of the isolator and the instructions. I set up a bench test, which is what I like to do before I do any final installation, just to make sure I have everything right and make sure that nothing needs to be replaced or returned, because it'll be a real pain in the ass to have everything installed permanently and then have to pull something out because it's not working. So this is all loosely installed for now. I have the isolator zip tied to my battery tie down. It's actually sturdy enough that if you wanted to do this way, you could just leave it here. But so per the instructions, that post with the red dot is where the hot from your starter battery comes from. So that wire, positive terminal, is going to that red dot. And then the charge out is this wire here. So that goes on the other post. And that's coming out and into the positive on this battery. When all is said and done, I'm gonna take that wire through that hole that I showed in the back of my tray, and it's gonna come to the positive on this battery, because this battery is where I'm pulling the ground for my shunt. So I want to sort of equalize it, positive to this battery, negative to this battery. So the isolator has a negative wire that I have coming off of the load out for my shunt, and that I just slid down on this stud for now, the stud for my battery hold down. The negative, or the ground for the isolator itself, I just ran to the negative terminal on my battery. So I have my monitor hooked up. What I'm gonna do now is fire the engine up and make sure that everything is working. If all goes well, what should happen is my screen should light up and I should get two little arrows on top of this battery pointing up, and that means that I'm getting a charge to my auxiliary battery bank from the isolator, because right now my starter battery is fully charged. If my starter battery was low and it needed to be charged, if it was below, maybe it was 11.5 or something, and it needed to be charged, the isolator would sense that, and it would send only it would stop the charge from, it would bring the charge in from the alternator, and it wouldn't send it out to the auxiliary battery bank until my starter battery was fully charged. Once that battery gets a full charge, then the isolator will read that, and it'll send the charge out from the starter battery to the battery bank. All right, it's the moment of truth. Isolator's in, all the wires are tight, connections are tight. About to fire the engine up. What should happen is when the engine comes on and the alternator starts sending a current to the starter battery, right now the starter battery is fully charged, so the isolator should sense that, and it should send the current in through this wire here to my battery bank. And when that happens, my Renogy battery monitor should sense that, and my screen should light up, and I should see two little arrows on my little mock-up battery here. And so if that happens, then basically I'm ready for the final install. So I'm gonna go ahead and fire it up. Let's see what happens. Yep, there it is. I got a charge going to my bank. There's my two arrows. The screen is pulsing. That means that there's a charge going to the bank. Doing a good job?